Hi everyone, in this lesson we're going to look at calculating a percentage change with a calculator. So let's jump into our first example. A house is valued at £325,000. After a crash in the housing market, it is later valued at £178,750. What is the percentage change in the house price? We have a formula for percentage change as follows. The percentage change is equal to the change divided by the original multiplied by 100. The change is going to be the difference in the house prices, so £325,000, subtract the £178,750. Now, oftentimes this formula is defined as the final subtract the original, and we've not done it that way round. We've actually done the original, which is this one, subtract the final. But that's okay, as long as I just interpret at the end of this, whether it's an increase or a decrease, then that's okay. The original was the £325,000, and we want to multiply that all by 100. So I'll go over to my calculator, and what I'll do is I'll put in the fraction bar using this button. I'll type in the £325,000, and I'll take away my £178,750 and put my denominator as 325,000, multiply that by 100. And it gives me this answer of 45%. Okay. Now I just need to use my common sense and write whether that's an increase or a decrease. Well, the house was valued at £325,000. It's a crash in the market. It's now valued at this. My answer is a 45% decrease. And it is important that we write this final line. Pause the video, give this question a go, and your answer will pop up on screen in a second. So the answer for that one is now on your screen. You should have got an answer of 90%, and because the deer population went from 850 up to 1,615, it's a 90% increase. Another type of common percentage change question is what's called a percentage error question. Let's have a look at this one. Philip wants to estimate the value of root 2. After completing his calculation, he gets an approximate value of 1.4375. Calculate the percentage error in his answer. Give your answer to 2 decimal places. And like percentage profit, percentage change, and so on, we have a formula for percentage error, and it's as follows. Percentage error is equal to the experimental value, subtract the actual value, divided by the actual value, multiplied by 100. Now, the reason it's called the experimental value is because it might be something that we've measured in an experiment, or in this case, it's the value that Philip's worked out, the 1.4375. That's why we call it the experimental. The actual value is, as it says on the tin, what the actual value is. In this case, it's our root 2, as you type in your calculator. Or if you were doing a measurement question, it is what the actual value is. So let's plug in our values for this. The experimental value is what Philip calculated. It's the 14375. We'll take away the actual value, that is root 2, as you just put that in your calculator, of course, divided by the actual value, multiplied by 100. Now, this might give us a negative answer, and that's okay. We just make it positive. That's what's called taking the magnitude. We're just interested in the size. We're not interested in the direction, whether it's negative or positive. So let's go over to our calculator, type in our fraction button, type in Philip's value, that's our experimental, the 1.4375, and we're going to take away root 2. Now, root 2 we do by typing this button, and then put our 2 in there, and then of course root 2 on the denominator as well. That's our actual value. And effectively what we're doing here is working out the difference between what Philip measured, or calculated rather, the actual value of root 2, and we want to see what is that error, what's the difference between those relative to the actual value. Multiply that by 100, and it gives you this answer of 1.646599796. I always recommend writing out the full calculator display. That's what I was taught to do at school, so I've got into that habit. And then it says give your answer to 2 decimal places. So we'll go to the second decimal place, that's the 4, and then we make our decision based on this digit. If the digit is 5 or greater, it tells us we need to round that 4 up to a 5. So it's a 6. So this goes up to 1.65%. And I like to put the accuracy in the brackets, that's to 2 decimal places. Just to interpret what that number means, it means the difference between what he calculated and the actual value is 1.65% of the actual value. And that's his percentage error. Pause the video and give this question a go, and then I'll go through your answer in a second. So Ellie wants to estimate the value of pi. After completing a calculation, she gets an approximate value of 3.16. Calculate the percentage error in her calculation. Give your answer to 2 decimal places. Let's write out our formula. Percentage error is equal to the experimental value, subtract the actual value, divided by the actual value, multiplied by 100. In this case, the experimental is what she calculated, the 3.16. The actual value is pi as seen on our calculator. And of course, that's on our denominator as well. So this is my calculation to type in. I go to my fraction button, I'll type in 3.16, subtract. To get pi on my calculator, it's up here. As you can see, it's in this yellow gold writing, and so is the shift button. So it's kind of like the shift keys on your computer board. You need to hit the shift key, and then you hit the button 7, and it gives you the pi. And we need to do that again on the denominator, multiply that by 100. And then it gives me this value of 0.5859240341%. And we need to round that to 2 decimal places. So I go to my second decimal place, that's the 8, draw a line after it. The 5 tells me I need to go up. This 8 needs to go up to a 9. It's 0.59%. And that's to 2 decimal places. Another common example of a percentage change question is a percentage profit or percentage loss question. Let's look at this one. An electronics shop purchases 400 used tablets. The listed price for each tablet is £150, but the shop secures a discount of 20% off the total order. Upon arrival, 1/10 of the tablets are found to be water damaged and cannot be sold. Half of the tablets are sold at a price of £140 per tablet. The remaining tablets are sold at a discount for £95 each. Calculate the shop's percentage loss on the tablets. Let's start off with where we want to end up in this question by defining percentage loss. Percentage loss is equal to the loss over the cost relative to the cost multiplied by 100. This gives us a formula to work from. We want to work out percentage loss. To do that, we need to work out the loss and the cost. Let's do each of these in turn. Let's work out the cost. Let's go back to our question. The electronics shop purchases the 400 used tablets. The listed price for each tablet is £150, but the shop secures a discount of 20% off the total order. So let's work out the cost of the order. Well, it would be the 400 tablets multiplied by the £150 for each of them. But then we want to reduce that. So we actually want to take 20% off that. Now, a 20% reduction is a multiplier of 0.8. And how I got that is if I start with 100%, that's my normal order. I've taken 20% off. That means the order that I'm actually getting is 80% of the value. And to turn that into a multiplier, divide by 100. So this is equivalent to a 20% reduction. So I'm going to multiply the normal cost by the 0.8, the 20% reduction. So I'll say the cost is equal to, and I'll type that in my calculator. I don't actually need the bracket. I'll just put that in for your benefit. The 400 tablets multiplied by £150 each, taking off 20% by multiplying by 0.8. And that gives me quite a lot of money. So the cost is £48,000 for the tablets. Let's keep going with the question. So it says, upon arrival, 1/10 of the tablets are found to be water damaged and cannot be sold. Half of the tablets are sold at a price of £140 per tablet. Let's just take each of these bits of information in turn. 1/10 of the tablets are water damaged and cannot be sold. Let's work out 1/10 of the tablets. So 1/10 of the tablets is equal to 1/10 of the 400 tablets. 1/10 is the same as dividing by 10, so that's going to be 40 tablets that are damaged. Okay, let's bear that in mind for later. Half of the tablets are sold at a price of £140. Let's work out half of the tablets. So the half of the tablets is going to be equal to half of the 400. So that's equal to 200 tablets. And I'm just working through each piece of information at a time. Half of the tablets are sold at a price of £140. So let's call this some income. And this is going to be equal to, well, half of the tablets, that's the 200, multiplied by £140 per tablet. And I'll do that in my calculator. So 200 multiplied by 140 give me an answer of £28,000 for these tablets. And the reason I'm working out my income is so that I can then take away the cost to find out what I lost. Half of the tablets are sold at a price of £140. The remaining tablets, so I don't know what that is, need to work that out, are sold at a discount for £95 each. Let's work out the remaining tablets. It's always good to use words in our questions. It just helps the person reading it to follow it, and it helps us as well. Remaining tablets. Well, what it means by remaining tablets is whatever is left over after we've discounted the damaged 40 tablets and half of the tablets that have already been sold. So to do that, we'll take our 400 tablets and then just take away 240, which is a combination of the half that was sold and the 40 that were water damaged. And you type that in your calculator and it would give you 160 tablets remaining. And it says these remaining tablets are sold at a discount for £95 each. So we got more income. So say the income is equal to 160 of these tablets multiplied by the £95 each. We'll do our 160 multiplied by 95. And that gives us £15,200 of income. We'll say our total income is what we got for the tablets above, so the £28,000. And then we're going to add on our £15,200. And we'll see what that gives us. So 28,000. Ready? Add on our 15,200. Gives us 43,200. We've worked out our total income. We know our total cost is 48,000. We can now work out our loss. So if you imagine the shop spent £48,000 getting these tablets, but they only actually got 43,200 back. So the loss is going to be the difference between these two numbers. So the 48,000 subtract the 43,200. So the loss to them is the difference between these. 43,200 is already in my calculator as the answer. All I have to do is do 48,000 and then I subtract the answer. Remember that's stored as the 43,000. Gives us this, so £4,800 loss. Last thing to do is to now work out our percentage loss. So I'm running out of room. Let's just siphon that off. So the percentage loss is the loss of £4,800 over the cost, which we said was £48,000, multiplied by 100. Go in our calculator and type this in. So 4,800. You might be able to spot that this fraction is 1/10, and that's great if you can spot that. But we'll go ahead and type it in anyway, just to check. And it gives us this answer of 10%. So my final answer was a 10% loss. Pause the video and give this question a go, and we'll look at it together. A family farm harvests a crop of 4,500 kilograms of potatoes. The total cost to cultivate, harvest, and package the potatoes is £1,200. The farm sells 3/5 of the harvest directly to a supermarket chain at a rate of £0.55 per kilogram. They sell 25% of the total harvest to local chip shops and markets at a rate of £0.48 per kilogram. The remaining potatoes are sold in bulk to a crisp manufacturing plant at a discounted rate of £0.3 per kilogram. Calculate the farm's percentage profit on this potato harvest. Give your answer to one decimal place. Let's start with writing out what percentage profit is. So percentage profit is equal to profit divided by cost multiplied by 100. So we know what we need to get in order to work out percentage profit. Let's start by looking at our costs and our incomes. Our costs, let's see what that is. The total cost, so this is everything, to cultivate, harvest, and package the potatoes is £1,200. So that's 1,200. That's my total cost, nothing else to do in that regard. Let's then look at our income. So the farm sells 3/5 to a supermarket chain. So supermarket's one source of income. Local chip shops and markets are another source. And the remaining potatoes are sold in bulk to a crisp manufacturing plant. So 3 different sources of income. Let's look at the supermarket income first. So the supermarket income, let's have a read of that. 3/5 of the harvest. So 3/5 of the 4,500 kilograms is sold directly to a supermarket chain at a rate of 55 pence. So this calculation will get me what I want. Just include my units. So just to show you what I've done here, I've done 3/5 of the harvest. So just multiply those together. That's going to give me the total kilograms sold to the supermarkets. And then I've multiplied it by the price per kilogram. I'll type this in my calculator. One big calculation. So 3/5 multiplied by the 4,500 multiplied by the 0.55. That gives me an answer of 1,000. This is in pounds, of course. 845 pounds to the supermarket. Okay. Going on, it says they sell 25% of the total harvest to local chip shops and markets. So let's look at chip shops and markets. We'll just say chip shop income to be short. And that was 25% of the total harvest. As a decimal, that's 0.25. So 0.25 multiplied by the 4,500 kilograms is going to give me how much they sold to the chip shop. And the rate was 48 pence, so 0.48 pounds per kilogram. That's my next calculation. 0.25, you could also type in 25%, that would also work. Multiplied by the 4,500, multiplied by the 0.48. And that gives us 540 pounds. And the last source of income, the remaining potatoes are sold in bulk to a crisp manufacturing plant. So that's the remaining potatoes. Now it's worth us working out how much the remaining potatoes are. So we'll say remaining potatoes is equal to, and we don't want to redo all our working out. We've already worked out how many potatoes went to the supermarkets, and we've already worked out how much went to the chip shops. So what I want to do is I want to take the total potatoes, so that's this number, and then I want to take away what has went to the supermarkets, so that's the 3/5 of the 4,500 and the 25% of the 4,500. So I can just take away both of these. And it's one of the downsides of not actually ever writing down what that number is, but it's okay. And we'll take away the 25% of the 4,500 as well. So let's do that in our calculator. 4,500 subtract 3/5 of 4,500 subtract 25% of 4,500. And that gives you 675 kilograms left over. Of course, the other way to do it would be to work out what fraction of the potatoes are left over. So do 1, take away 3/5, take away 0.25, and then multiply that by the total. But this is just the way I've done it because we've already worked out that number and that number. So the remaining potatoes is 675 kilograms. So I'll take the 675 kg and multiply that by how much I got for these. Well, it says 30 pence per kilogram to the chip shop. And then I'll multiply this number. Notice I just hit the multiply button. It's stored as my answer. Then type my 0.3 and that into decimal. And it gives me this answer of 202 pounds and 50 pence. Let's look at our total income. So total income is equal to, well, I'm just going to add this number and this number and this number together. I've already got this number, so I just need to add on 540, add on 1,485, and it takes me to a total of 227.5. So 2,227 pounds and 50 pence. Okay. So lots of working out for this question. We know our costs are this. We know our total income is this. We can work out our profit. Our profit is equal to the difference between our income and our costs. That's going to be the difference between our 2,227 pounds and 50 pence and the 1,200 pounds. Again, this is stored in my calculator, so I just type the subtract button. Answer stored that. Type in my 1,200. And it gives me £1,000 and 27.50. Okay. Last step is to come over and do my percentage profit. So percentage profit is equal to my profit, which we've just worked out as being this, divided by the costs, which was the 1,200, multiplied by 100. So my answer is already stored as this, so I can go to my fraction bar. My answer is going to be going on the numerator. The 1,200 is on the denominator, multiplied by 100. Gives me this number, which is 85.625%. So they make 85.625% profit. It's always worth checking if our question asks for a specific degree of accuracy. It does. It says give your answer to one decimal place. Draw your line after the first decimal place. The 2 tells me that I'm not going to round the 6 up. So it's going to stay as 85.6%. And this is to one decimal place. So well done if you got that as your answer. All right, our next example is an area and perimeter example. Let's have a look. Rectangle A has side lengths of 20 centimeters and 50 centimeters. The side lengths of rectangle A are increased by 40% to form rectangle B. Find the percentage change in the area from rectangle A to rectangle B. This question I'm going to start by doing a diagram. So rectangle A has side lengths of 20 centimeters and 50 centimeters. So 20 centimeters and 50 centimeters like this. That's rectangle A. And it says the side lengths of rectangle A are increased by 40%. So they've been increased by 40% to form rectangle B. So I'll draw rectangle B a little bit bigger, like this. Okay. The first thing I'm going to do is I'm going to work out the new side lengths. And to do that, I need to know what the multiplier is for a 40% increase. So let's say that a 40% increase, and we've covered that in previous lessons, so if we always imagine we start with 100%, and if we've added on 40%, that takes us to our new percentage, which is 140%. In other words, that's what rectangle B is relative to rectangle A. To get a multiplier that allows us to go from A to B, I turn the 140% into a decimal by dividing by 100. That's 1.4. In other words, I multiply by 1.4 to get the new side lengths. Let's do this side length of 20 first. So I'll go to my calculator and increase it by 40% by multiplying by 1.4. And that takes me to 28 centimeters. And then I'll go and I'll take my 50 centimeters and I'll increase that by 40% as well. And that gives me an answer of 70 centimeters. Find the percentage change in the area from rectangle A to the area of rectangle B. Let's work out the area of A. The area of A is a rectangle, so multiply your width and your length together. So 20 multiplied by 50. Go ahead and do 20 multiplied by 50 to give us 1,000 centimeters squared. And then we'll look at the area of rectangle B. That gives you 1,960 centimeters squared. To work out percentage change, I'm going to do the change divided by the original multiplied by 100. So the change is the difference between the 1,960 and the 1,000 relative to the original, which is the 1,000 multiplied by 100. Let's type that in the calculator. Subtract 1,000. Divided by 1,000, multiplied by 100. It gives me an answer of 96%. Find the percentage change in the area from rectangle A to rectangle B. My answer is 96%. Now remember, we always have to say if that's an increase or decrease. My answer is it's a 96% increase. If you're doing this question, you might be tempted to say, well, if the side lengths have increased by 40%, then surely the area has also increased by 40%. And you would be wrong to say that. The reason that the relationship between the areas is not also a 40% increase is because if you think how you got the new area, well, you increased this side by 40%, and you increase this side by 40%. Another way to do the question, which is actually a lot easier, but I did want to show you this way, is if you think that you've multiplied your first side by 1.4, in other words, a 40% increase, and you've multiplied your second side by 1.4, this is going to be equal to your overall multiplier for the area. In other words, the area multiplier is the length multiplier squared. If I type in the 1.4 squared, if you notice, it gives me an answer of 1.96. In other words, area B is 1.96 times bigger. So if I wanted to write that mathematically, I might say to go from area A to area B, I need to multiply by 1.96. And then what I could do is I could just interpret 1.96 as a multiplier as being equal to 196%. In other words, area B is 196% relative to area A at 100%. Therefore, I can see that that's a 96% increase. So that's another way to do the question, but I did want to show you using the percentage change formula. Pause the video and give this question a go, and then we'll run through it together. Make sure to draw a diagram to help you. So square A has an area of 16 centimeters squared. The area of square A is increased by 56.25% to form square B. Find the percentage change in the perimeter from square A to square B. Let's draw square A. And square A has an area of 16 centimeters squared. I would already be thinking that that means it has side lengths of 4 centimeters. And the area of square A has been increased by 56.25%. I want to go ahead and turn that increase into a decimal multiplier. To do that, remember we start with 100%, that's your square A. We've gained 56.25%. That takes us to 156.25%. Turn that into a decimal multiplier by dividing by 100. It gives you this multiplier of a 1.5625 multiplied by 1.5625. Now, if you noticed, it was the area that was increased, so I do have to be careful there. The side lengths have not been increased by that much, but the area. I'll draw out my new square, not the best drawer in the world. And I'll take my area of 16 centimeters squared, and I'll increase it by 1.5625. 16 multiplied by that gives me this area, which is 25 centimeters squared. So a nice square number. We are glad to see that. Write that in, 25 centimeters squared, which means my side lengths are 5 centimeters because it's a square. I know that the sides are the same length, so 5 multiplied by 5 gives me my 25 centimeters. Find the percentage change in the perimeter from square A to square B. Let's look at the perimeter of square A. Well, the perimeter is the distance around the outside of the shape. It's a square. There are 4 sides, and each of them are 4 centimeters. So the perimeter is 16 centimeters. Notice that the units are centimeters, not centimeters squared, because it's perimeter, which means it's a distance, not an area. And this is an example of where the area and the perimeter are actually the same value. So both of them are 16. That's not always the case. Perimeter B. Again, there are 4 sides to this shape. It's a square, and each of the sides are 5 centimeters. That gives you a perimeter of 20 centimeters. So notice this time the perimeter and the area are not the same. We want to work out the percentage change from A to B. So from A means that A is going to be our original. So I'll say the percentage change is equal to the change divided by the original multiplied by 100. The change is the difference between 20 and 16, which is 4. The original perimeter was 16, like this. And I typed up my calculator. 20 subtract 16 is 4 over 16. I'm already seeing that that's going to be a quarter. So you might be able to jump ahead and know that it's 25%, which my calculator confirms. So find the percentage change in the perimeter from A to B. Just check that it is an increase. Well, it went from 16 centimeters squared to 25 centimeters squared. So my answer is a 25% increase. For those of you who are interested, you might want to think about this puzzle. The square root of 1.5625 is equal to 1.25, and 1.25 is equal to 125%, which is equal to a 25% increase. You might want to have a think about how you could do the question using this method if you want, but we're not going to go over that because this is not the main purpose of the lesson. The last example we're going to look at is a successive percentage change. A clothing shop is having an end of season clearance sale where all items are discounted by 25%. During the final week of the sale, an additional discount is applied to the already reduced items, bringing the overall effective discount to 40%. Calculate the percentage of this additional discount. So what I recommend is taking questions line by line and seeing what you can work out in each line. A clothing shop is having an end of season clearance sale where all the items are discounted by 25%. Well, what I can do is I can work out the multiplier for a 25% discount. We start with 100%. We've lost 25%, which is equal to 75%. Turn that into a multiplier by dividing by 100, it's 0.75. So that's my discount of 25%. I'd have multiplied my items by 0.75. During the final week of the sale, an additional discount is applied to the already reduced items. Now, it doesn't tell us what this discount is. That's, of course, what we need to find. So I'm going to let that be equal to either X or Y or some algebra term because it's an unknown. Bringing the overall effective discount to 40%. Well, can I work out what the multiplier is for the overall discount of 40%? Well, yes, I can. I've taken my 100%. Overall, I've lost 40%, which is equal to 60%, which is equal to a 0.6 multiplier. So that's my overall multiplier. Now, you might be tempted to think, well, if we've lost 25% and then we lost something else, but overall it's a loss of 40, the difference between 25 and 40, which is 15, is the unknown percentage discount. And you would be wrong to think that, and we'll look at why that's true in a second. Calculate the percentage of this additional discount. Let's let y be equal to the multiplier for the additional discount. Okay, let's imagine what's happening in this question. You have a clothing shop and they've discounted all the items by 25%. In other words, they multiplied all of the items by 0.75. This 0.75 corresponds to the 25% discount. During the final week of the sale, an additional discount is applied to the already reduced items. We don't know what that additional multiplier is yet, but we've said that it's y, bringing the overall effective discount to 40%. So whatever these two numbers are multiplied together, it gives me this overall effective discount of 40%, which we represent as a 0.6 multiplier. This is a 40% overall reduction. Now what we can do is we can form this into an equation. We've got 0.75 multiplied by y, and that's equal to 0.6. If we divide both sides of this equation by 0.75, it's going to allow us to work out what the value of the unknown multiplier was. So I'll go into my calculator, I'll do 0.6 divided by 0.75, and it gives me an answer of 0.8. So that was my unknown multiplier. Then what I need to do is I need to interpret this multiplier. If y is 0.8, as a decimal. As a percentage, if we multiply that by 100 to turn it into a percentage, that's 80%. We had our items in the shop. They were discounted by 25%. In other words, we were left with 75%. That's the 0.75 multiplier. Then we multiplied it by our 0.8 multiplier, which is 80% of whatever's left over, which give us this effective discount overall of 40%, meaning we had 60% left over. So remember, we interpreted this as a 25% decrease. We interpreted this as a 40% decrease. So that means we can interpret our unknown multiplier as a 20% decrease. We always start with 100%, so we just want to work out the difference between 100% and 80%. So this is the calculation that I did to do that. 100% take away 80% is a 20% reduction. So my answer is a 20% discount was applied. Pause the video and give this question a go, and then we'll have a look at it together. An investor puts £5,000 into a high-risk index fund. In year 1, the value of the fund increases by X%. In year 2, the value of the fund decreases by 7%. At the end of year 2, the investment is worth £5,208. Find the value of X. This question is slightly different to the one before. We can actually work out the percentage change because we know the original value and we know the final value, so we know the change. Let's say the percentage change is equal to the change divided by the original multiplied by 100. The change is the difference between the 5,208, because that's it, and the £5,000. And the original value is the £5,000. This is going to work out our overall percentage change. So I'll type that in my calculator. 5208 subtract 5,000 divided by 5,000 multiplied by 100. And it gives me this answer, a 4.16% increase. And the reason I know it's an increase is because we went from 5,000 up to 5,208. So this is the overall percentage change. So I should have written that the first time. We'll say it's the overall percentage change. And it's a 4.16% increase. Let's think of that as an overall multiplier. So remember, to get our multiplier for these, we always start with 100. We've gained 4.16% overall, leaving us with 104.16%. To turn that into a decimal, I divide by 100 to give me 1.0416 as a multiplier. And I know that this overall multiplier is going to be equal to the two individual multipliers multiplied together. In year one, the value of the fund increases by X%. So we don't know what this X% is. Let's let the multiplier for this be equal to Y. Let the unknown multiplier be Y. And the reason I called it Y and not X is because the value that it increases by is not identical to the multiplier. So we want to work out the multiplier first and then figure out the percentage. In year two, the value of the fund decreases by 7%. So that would be equivalent to this. So starting with 100%, we've lost 7%, giving us 93%, which is equal to a 0.93 multiplier. And at the end of year two, the investment is worth this. Find the value of X. So what we've got going on here is our overall multiplier is equal to our first multiplier, which we've said is Y, multiplied by our second multiplier, which was the 0.93. We know our overall multiplier is 1.0416. That's equal to Y multiplied by 0.93. We can work out the value of Y by doing 1.0416 divided by 0.93. 1.0416 divided by 0.93 gives me an answer of 1.12. Okay, and we just need to then interpret this multiplier. So Y is equal to 112%. Remember, we always start with 100%, so if we ended up with 112% and we started at 100%, if we take 100% away from this, we can see it's a 12% increase. So in year one, the value of the fund increases by X%. Find the value of X. The answer is X is equal to 12, because it's a 12% increase. If you're using our lesson booklets, you can now complete exercises 1 to 3. Thank you for watching the video.